on SoundCloud. You could. ChatGPT, make a mixtape for my calculus class. All right, calculus AB. It is Wednesday, April 12th. All right, let's keep going. We're going to start with the 8.6 notes, or 8.7, sorry. Okay, volume with cross sections. I don't know why these are considered two different lessons. They're the exact same thing. Okay. Yeah, so I was just kind of doing problems this morning. I'll stop saying and actually do something. All right, so if you want to find the area of a square, all right, this is hard, okay? If you want to find the area of a square, what do you need to know? The square's side length, right? And what's the formula for the area? Okay, thank you. Good. Ahead of the curve, we're ahead of the curve. What do you need to know for finding the area of rectangles? Length and the width, right? And then what's that area formula? Area equals length times width, right? What about a semicircle? You need to know what? Radius, and what's that area formula? Yeah, pi r squared over 2. What? Okay. And then triangle. B and H, right? Area is 1/2 base times height. Look at that. Look at that. All right, let's add one more. What about for an equilateral triangle? What do you need to know? Not all at once. You need to know what? Side length, right? S, and what is that area formula? Anyone know? Root 3 over 4a squared. All right, questions, comments, concerns? All right, cool. All right, then we hit him with the triangle base, okay? So here's what's going on. Here's what's going on, okay? Here's what's going on, okay? So they're going to give you a region bounded by these two graphs. I'll make this the red one, okay? Let's graph the red one, right? That's a line. That's negative x over 2 plus 1. So it goes from here to here. Okay, let's make that the other one the blue graph. Love graphing. And x equals 0. So this is our base. This is the base of our solid, of our surface. That's the bottom of it, okay? So if you're looking, if you were like, we're trying to find the volume of a figure whose cross sections are squares and whose base is that region. So if you were looking at the bottom of this figure, you'd be looking at this triangle, okay? Okay? The cross sections are squares, okay? I, for 99 cents, downloaded a helpful app. Okay? So this is what we're working with? No. Okay. So this is what the figure looks like. So we're looking at here. Here we go. We're looking at the bottom of it. Okay. So there's my region. Here's that region. Okay. And the figure is basically a bunch of squares stacked on top of each other above that region. Okay? Weird, 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 weird. Okay? Right? We want to find the volume of that. Okay, how do you think we're going to do this?
B over A to A of x dx.
Okay, so in general, how would I find the volume of a shape like this, you think? It's a bunch of squares stacked on top of each other with that triangle as its bottom. How would I find the volume of one little slice? It'd be, so one little slice, it's just a bunch of squares stacked on top of each other, right? So to find the area of one of those squares, I just do side squared, right? So so for each of these squares, the side length is given by the distance between this top and bottom graph, right? If these are a bunch of squares stacked on top of each other like this, right, then the sides are going down top to bottom, right? Okay. That's going to be the length of a side, right? It's going to be these little, just a bunch of little squares, right, stacked on top of each other, okay? This is a little bottom view, okay? So each of these orange stripes is the side of a square. What's the area of that corresponding square going to be? The length of the orange striped square, right? How do we get the length of each of those orange stripes? It's going to be the blue curve minus the red curve. Okay? So we're going to do blue minus red, or red minus blue. Let's do that subtraction real quick. Going to give you 2 minus x, okay? So if you just give me a value of x, then the length of the square that's at that value of x is going to be the red curve minus the blue curve, or 1 minus x over 2 minus negative 1 plus x over 2, okay? That simplifies to 2 minus x, okay? Then what's the area of the square whose bottom side is that orange stripe? It's going to be 2 minus x squared is going to be the area, okay? And how do we go from area to volume? What's that? No, I think you're on the right track. Then we want to add up all the squares, okay? So we're going to integrate that from x equals 0 right here to x equals 2. Okay. Questions, comments, concerns? All right, so it's a little confusing at first, and at second, and third and fourth, okay? But it'll get easier over time. All right, someday you're going to be standing up here. All right, check out this. All right, high school. And for the 0 stuff, when I plug in 0, all my terms just give me 0, so I don't have to write those down. All right, and then just evaluate your exponents, and you're good. You're a 4 function. Questions, comments, concerns? All right, so this yellow region, that's the bottom of our little figure. Okay. So it ends up being 8/3. Okay. Now what's happening? This is a little bit the same bottom. Our shape has the same bottom. Our figure has the same bottom. But now the cross sections of it. Now this is the bottom of a shape whose cross sections, or the top side, is a bunch of semicircles. Okay. So here's our bottom, right? The little bottom triangle. Okay. So if we were to rotate it, if I were to take it off the page, if I were to had superpowers and right? Now I were to flip it around, it would look like a bunch of semicircles, okay? So if we're looking at the bottom of our shape, what's the radius of each of these semicircles going to be? So we can look at it this way, right? Right, the radius goes from here to here, right? That's the radius, okay? The radius. Okay, let's look at that with a bottom perspective. Let's look at that on the bottom. Okay, you guys see in our little triangle region here, right? The radius is here to here. Okay, so the radius of each semicircle is just the stripe that goes from the top function down to the axis. Okay, so that's going to be just the height of each semicircle is just going to be the top function. So or the radius, sorry, the radius. So radius equals 1 minus x over 2. That's going to be the radius. What's the area of each semicircle going to be? It's a semicircle. Pi over 2 times r squared, right? It's going to be the area. And then how do I get the volume? Add up all the areas. So the volume is going to be the integral of pi over 2 times 1 minus x over 2 squared dx from x equals 0 to 2. Okay. Questions, comments, concerns? All right, so doing this integral, it's easier if let's pull the pi over 2 out. And then let's combine this fraction here. Let's combine this fraction, combine that. Sorry, pull the pi over 2 out, sorry. There's not enough room in these notes, unfortunately. What's going to happen, we'll get 4 minus 4x plus x squared when we square it. That bottom, what's that bottom going to become when we square it? It's going to be divided by 4. So I'm going to pull that out. So it equals pi over 8. Notice we did this integral up here. Okay, so this is going to be pi over 8 times that integral. 4 times 2 minus 2 times 4 plus 1/3 times x. Four function. Questions, comments, concerns? All right, yeah.
So you multiply by 4.
What?
You multiply by 4, so you would be by 2.
I multiplied by 1/4.
Oh.
Right, because what happened was I'm trying to square this fraction, so I square the numerator, I square the denominator. When I square the denominator, it becomes an over 4, and I pulled the over 4 out. It became pi over 8. All right, how are we feeling? Okay. All right, this next one, the cross section's perpendicular to the x-axis. Now they're rectangles whose lengths are 3. Okay. Okay, so what's happening? I don't have a good function for that in this app. Let's go back to squares. Okay, so we've got our little triangular region, right? If we pop it off the page, right, now it's going to look like a bunch of rectangles. So instead of these being squares, they're going to be rectangles. So this length, instead of being, it's just going to be 3. It's just always going to be 3. Okay. So this is just 3, and then so the length of each rectangle is 3. The widths are going to be on the bottom. What's the width of each rectangle going to be? Right, so the widths are going to be at the bottom. You see how the bottom, so the width is going to be the distance from the top to the bottom, which is the top minus the bottom. Okay, so we're going to do top minus bottom again. That was 2 minus x. So the width of each one is 2 minus x. The length is 3. What's my area? Okay, 3 times 2 minus x, which is 6 minus 3x. So it says the cross sections perpendicular to the x-axis are rectangles whose heights are 3. Okay? And then those are my areas. To get the volume, I sum up all the areas. Questions, comments, concerns? Yes, no, maybe so. I gotta go to the post office today. Okay. And then, right, when I plug in 0, when I evaluate this function at 0, it's just going to go away. See that? So then, if I evaluate the exponent, you have 6 times 2 minus 3 half times 4. Don't have to keep going. Questions, comments, concerns? Let's do the last one, then go to lunch. You guys okay? Okay. Now we're equilateral triangles, okay? Now we're equilateral triangles. No, stop. So same bottom. Now my figure looks like this. So here's my bottom. Here's my bottom region. Okay, so this is the bottom of my shape. If we were to rip it off the TV, the top is a bunch of equilateral triangles. You see that? See, here's the bottom. Here are all the equilateral triangles. Okay, so what's the length of one side? Do you guys see how the length of this one side of each equilateral triangle is going to be the same as the height of the heights of the base again? Yes, no, maybe so. So we got the base, right? This is the bottom side. If I were to draw a vertical line in this region here, that's the bottom side of an equilateral triangle, right? Because it's just a bunch of equilateral triangles stacked on top of each other, right? That's this side, right? The height of each base, right? The height of the base is one side of an equilateral triangle. See that? Okay. So my sides are going to be what? Top minus bottom again, so 2 minus x. Okay. What's the formula for area then of each of those triangles?
3/3/4.
Yep. And then I want to add them all up from 0 to 2. And then we've done the integral like 3 times on this page. It is questions, comments, concerns? All right, 12:45. See you guys. Then we'll do a circular base when we come back from lunch.